So in this video, I'll be showing you how to convert an infix string to a postfix string. So before we start, I will include all the headers and the libraries we need. So in this video, I'll be using the infix string, this infix string. I already pre like wrote it down. I wrote it down already, so yeah, this is the infix string we'll be using. Yeah, so that's the string we'll be using. And the postfix of this infix string will be the following. Yeah, so like that. So now we will make the postfix function, the getting postfix function. So we're going to return a string. That string is going to be the postfix. So we're going to pass a string through, which will be the infix. And we're just going to do this. So in this function, we are going to first make a stack of characters, and we're going to make a postfix string. Oops. So once we have those declared and defined, we will make the loop for iteration of the infix string. Let me just change this so it's not confusing. Alright, so the first condition is going to be if the current character is a digit. So if that's the case, we simply just add it to the postfix expression or string. Yep. And then the next condition is going to be if it's an open bracket. If that's the case, we just simply add it to the stack. Like so. Your next condition is going to be if the current character is the operator caret. So when we think about PEMDAS, caret has, of all the operations, caret has the highest priority. So we're going to make a loop here while the stack isn't empty, and the top of the stack equals to another caret, and the top of the stack doesn't equal to open parenthesis. I will explain what this means once I'm done typing it. So basically, what happens here is yeah, so basically what happens here is if there's another caret in the stack, you want to perform that caret operation before the caret operation you're trying to, or the current caret character. So you want to do that operation before the current caret operation, basically. Yeah, so then the next condition will be for multiplication and division, because they are, according to PEMDAS, the next highest priority. and have the same priority. So we have this condition, and similar to the caret, we will have another condition for where the for what we're looking for at the top of the stack. So what we're looking for at the top of the stack, if it's not empty, is a plus or minus. Oops. So we're going to do the same thing. We're just going to add the things at the top of the stack and pop them if it runs through the while loop. And then we just push whatever is the current operator. So we have this condition because we want to do all the multiplications, divisions, carets, etc. before we insert the new multiplication or division operator. And similar to the last, similar to the caret, we have another condition for the open parenthesis, which is because we just don't want open parentheses in our postfix expression. So yeah. And then next condition is for addition and subtraction. They have the lowest priority of all the operators, but they are equal, so we use the OR condition there. And now for our looping expression, we have this so the reason that this is our condition is because since they're the lowest priority, anything that's in the stack already we want to do before it. So yeah, that's why this is this condition. And finally we have the condition for where the current character is a closing parenthesis. So for this we'll just simply do this. So we want to just add everything that's not a open bracket to the postfix expression. And at the end of it, we will do another pop because once this loop terminates, the top of the stack will be an open parenthesis, and we don't want to have open parentheses in our postfix expression, as mentioned earlier. And also we can get away with this condition. We don't have to check if the stack's empty because we're assuming that the closing parenthesis has a matching open parenthesis, so the stack's never going to be empty. So you don't need to put a condition for, you don't have to add a condition for if the stack's not empty. And then finally we have the final condition, which is this while the stack's not empty, because even if you finish iterating through the infixx expression, you could still have operators left in your stack, and that'd probably not be good to have your postfix expression not have every operator. So we just simply add the remaining operators into the postfix expression. Oops. And once we're done with that, we just return the postfix, and we are done. Hold up. Now we're done. So now we just say to postfix and then we see out p. And as you can see, this output matches this postfix that I previously had typed. And yeah, I hope this video helped. Next video, I'll probably do a postfix evaluation. So we're still going to use this function here. So yeah, I hope this video helped.